Hi, I'm Chiang Darrel. I'll be doing static malware analysis. So static malware analysis refers to the examination of the malware's functionality without actually executing the malware. So first off, we'll start with basic malware analysis, where we put inside virus total scanning. You can see over here 69 out of 73 security vendors flag this as a Trojan malware. Right down you can see the properties, and also you can see the contacted URL, domain, and IP addresses. These domains, URLs, and IP addresses may indicate a command and control server or just a remote host for the malware to exfiltrate data to. We can also look at the analysis report from other people. So the very first thing we want to do is the obfuscation and unpacking. So right now we put it in the PID. You can see that it's actually not packed, and it's actually compiled by Microsoft Visual C and C++. For the fingerprinting, we'll use ND5, WinND5 to create a ND5 hash. This can tell us that the malware has not been affected with the downloading and unzipping progress. For extracting strings, we will be using bin tags. So for the first string found, this is actually a domain. When inspected by VirusTotal, it's actually a malicious website that steals information. However, this might not be a domain also, which actually suggests that the malware is designed to evade detection and removal by antivirus programs. Next, we see this group of strings. We can see that it actually tries to steal this encrypted username, encrypted password from this Mozilla browser, after which it initializes this NSS, which is a cryptographic computer library, to decrypt the encrypted stolen data. Right now you can see this group of strings is actually the malware trying to go into different browsers and into the profiles to steal the credentials. Moving on, we can see this group of strings too. It is actually the malware targeting not only browser data but these email applications. And this specific Outlook application where the malware goes inside and steal the credentials from the profile in Outlook. Next is a very special string, a registry key called cryptography, which stores the cryptographic settings. Altering this will allow the malware to retrieve or modify cryptographic function to allow the malware to bypass and manipulate security mechanisms. For file headers and PE section, using PE view, you can see it's meant for Windows 32 and the timestamp date. Next, we'll be looking at dependencies with dependency walker. For main DLL, the first one, ws232.dll, is actually used to create a network connection. So first, the socket creates a network socket, and the send and receive function allows the malware to receive and send data. So the create thread allows the malware to execute payload, handle data, and communication simultaneously. So this set thread token function, very special. It allows the malware to assign an impersonation token to the thread with elevated privileges. The next few important functions we look at is find file, which actually searches for a file in the directory. Get volume information retrieves information about the file system and the specified root directory. This allows the malware to detect if it's in a virtualized environment. The next DLL, kernel32.dll. So the imported functions for this DLL, the first three imported functions support dynamic memory management, allowing the malware to allocate, deallocate memory, and the last two allow the malware to analyze cause of operational failure, indicating that this malware may be capable of handling certain errors and even continue to run afterwards. Some of the imported functions by this DLL: set cursor info, set cursor position, and console input actually simulate user input by injecting events into the console input buffer. So this could automate the input of commands or even open up browsers to steal credentials. The next imported function, a very important one, that allows the malware to peek into the console input. So this gives the malware spying capabilities and key logging capabilities, where the user type in on their keyboard and the malware can actually read what the user is typing. The next we'll be looking is compatibility cache. The malware will actually check the compatibility with its system, indicating that this malware is designed to be very persistent. Second last, DLL, OLE32. This actually creates instances of COM. So this component object module can be created by the malware to target at interacting with these sensitive files or data to steal information. As mentioned, it can actually import these functions to open the clipboard and steal the data within the clipboard, so when the users copy and paste their password or username, the malware can get it. Get shell window allow the malware to access the shell window. And lastly, the alert32.dll. This DLL by itself is not a malicious indicator. However, the malware can misuse this system allocate string and system free string such that it actually allocate memory for strings that hold sensitive data in such a way that it avoids detection for data exfiltration. Moving on to advanced static malware analysis, we'll be looking at this code from the IDEA, this assembler. So firstly, we'll be looking at the first subroutine. It actually reads a specific value from this machine GUID from the direct registry key. So this registry key will be read, and the malware may use this machine GUID as a seed to generate a decryption key to decrypt harvested encrypted data. So the next subroutine actually calls a function from this library. This library is an important security DLL that decrypts all local password hashes schemes on the computer. So this function, when called by the malware, it can be abused to decrypt encrypted stolen data. Next, this subroutine push various strings onto a stack, including password and username. This may indicate that the malware is actually preparing these strings to be exfiltrated. Next, we'll be looking at a group of code from this subroutine. Firstly, the get address information actually provides a hostname to address resolution. The socket function creates an endpoint for communication, and then the connect function initiates the connection to the socket. So this may be for the malware to exfiltrate data to or receive instructions from a command and control server. The next subroutine, it stores this offset HTTP and offset HTTPS where the strings are located. So the subroutine tries to process the URL by using the strings to prefix the URL, and then actually calls this function, potentially called to perform actual validation or processing the URL, like for example testing the network connectivity between the victim system and the URL. The program tries with the HTTP. If it fails, then it tries with the HTTPS. So these are actually network-based indicator to allow the malware to effectively connect with an external device. So this subroutine enumerates and access information from Windows Vault. Windows Vault is a place where the credentials such as password information and username are stored. This library is being pushed so that the malware calls the function from the library to enumerate the vault to get the information about the vault, and as well as extract stored credentials within the vault. The next DLL is actually a DLL that is used to implement certificate and cryptographic messaging functions within the crypto API. So after being pushed to the stack, right, a function within this DLL is called. This function actually can convert formatted strings into an array of bytes, or possibly be used by the malware to decode or convert encrypted data into human readable forms. So analyzing this subroutine, you can actually see that the code is pushing the password, user, and the hostname onto the stack, and then after that it calls a function. So from what I can analyze, that it's actually trying to prepare these credentials for a login attempt at the website or application. This may actually be part of a automated function within the malware to automate these login requests. So I've come to the end of my static analysis. So in general and in conclusion, I'm able to infer that this malware is designed to infiltrate systems and browsers and extract sensitive information such as credential, and then after that communicate with and possibly exfiltrate data to the external servers or a remote host. So also by understanding the virtual environment detection capabilities and compatibility optimization of the malware, I derive that this malware have a high level of sophistication where it has the ability to evade analysis, and also it has the advanced persistent mechanism which allows it to prolong its operation on the act of objective within the malware system. Thank you.